Hello, we are discussing about GATE 2012 ECE paper. Look at the circuit diagram. Both the voltage sources are in phase. Find the value of R for which maximum power is transferred from circuit A to circuit B. So we are going to find the value of R. This is for which circuit A is delivers maximum power to the circuit B. Generally maximum power is delivered. Maximum power is delivered for a R. If this equation satisfies, dP by dR is equal to 0. Differentiation of power divided with respect to R. If it is giving 0, that will be treated as the maximum power can be delivered for the value of R, dP by dR. Here P implies nothing but power delivered to circuit B. So I am saying it as dPB by dR. Power delivered to circuit B with respect to R. If you differentiate the power delivered to circuit B with respect to R and that is equating to 0, then you will get the value of R, which is going to be giving the maximum power transfer from circuit A to circuit B. So this is the important equation. In any circuit, not only for a circuit, in any theory, we know that one, if you want to find the maximum or minimum, if a curve is going through a maximum like this, then what is the maximum value can be calculated by going through differentiation of this circuit. Otherwise, if you have a one more circuit is going to be like this, what is the minimum value of this one, that can be calculated as with respect to differentiation only. So maximum value of power which delivered to circuit B from circuit A can be calculated by going through finding the power delivered to circuit B and differentiating it with respect to R. Now our aim is to calculate PB, power delivered to circuit B. But if you observe, circuit B is a complex network, so replace it with Thevenin's equivalent circuit. Thevenin's equivalent circuit. So replace circuit B, and that too you are replacing across these two terminals by looking into this circuit. So Thevenin's equivalent circuit, we know that one, it will be consisting of a Thevenin's voltage and Thevenin's resistance. So this is the terminals, it is 10 volts. These are the terminals. Now this is circuit A and circuit B is replacing with a Thevenin's voltage equivalent. So this is equal to RTH and it is VTH. Now we need to calculate RTH and VTH values because we know the values of circuit A. And from we are going to calculate power delivered to circuit B. So first of all, VTH means open circuit voltage at terminals of interest. Open circuit voltage at terminals of interest, that means this is the voltage. You are going to find this circuit is going to be kept open, these two terminals. By that time voltage across this one is 3 volts, that is also you will get it as across capacitor because both are in parallel, so you will get 3 volts here also. And since it is open circuit, no current flows into this resistor, so that voltage drop across this resistor is 0. That means it is acting as short circuit. So whenever it is acting as short circuit, simply it is going to be replacing with a wire. So VTH, voltage across open circuit voltage at the terminals of interest, which is VTH, that is also equal to 3 volts. So VTH, what we have seen is 3 volts. And now we are going to calculate RTH. RTH is Thevenin's equivalent resistance across the two terminals. So across these two terminals, what is its equivalent resistance? equivalent resistance can be calculated by short circuiting the voltage source and open circuiting the current sources if exist. So now this circuit is only consisting of voltage source, so you must make the short circuit. Short circuit means impedance of this one is going to be 0 ohms. So 0 ohms in parallel with impedance X. So the effective is going to be 0 itself. Capacitor doesn't have any effect. Okay, because across the capacitor there is a voltage source which is acting as short circuit while calculating the R Thevenins. So now the resistance present is only this R. Okay, RTH is equal to R and VTH is equal to 3 volts. Okay, because we know while calculating Thevenin's resistance, voltage sources will be short circuit. Then if voltage sources is short circuited, this doesn't have any effect. Then what you find is only this resistance R. So RTH resistance between these two terminals is R plus 0. That is total is R itself. RTH is equal to R. Okay. Now this is a circuit. We are going to find current flowing through it. I can be written as 10 minus VTH. VTH is equal to 3 volts. So 10 minus 3 divided by total resistance, that is 2 plus R, that I am writing it as R plus 2. So 7 by R plus 2 is the current. Okay. Now we are interested in the calculation of power delivered to circuit B. Power delivered to circuit B. So which is nothing but PB. PB is equal to PB consisting of two parameters, that is RTH and another is VTH. Power across RTH and power across VTH. Power across RTH is nothing but I square into RTH and voltage across RTH is VTH into I. So simply PB is equal to I is equal to 7 by R plus 2. 7 by R plus 2 whole square into RTH. RTH is nothing but R itself. VTH is 3 and I is equal to 7 by R plus 2. So now PB can be simplified as, after simplification you are going to get it as 70R plus 42 divided by 2 plus R whole square. 2 plus R whole square. And now differentiate this equation with respect to R. So dPB differentiate PB with respect to R. Use U by V formula. Differentiation of U by V formula. So the differentiation of U by V formula is going to be, okay, U into V into U derivative minus U into V derivative divided by V square. So here you are going to get it as 4 square, that is equal to 0 dP by, and V into U derivative 2 plus R whole square into, okay, this is U and V derivative with respect to R, it is 70 minus, okay, 70R plus 42, this is U. V derivative is nothing but 2 times of 2 plus R. 2 times of 2 plus R. And this 2 plus R to the power of 4, if it is going this side, it will become 0. And after simplification, okay, you are going to get it as minus 70R plus 56 is equal to 0. Minus 70R plus 56 is equal to 0. And R value is equal to, okay, this is 56 by 70. 56 by 70 means 0.8 ohms. Okay. So R value required, the value of resistors for which maximum power is transferred from circuit A to circuit B is 0.8 ohms. 0.8 ohms means option is A. So the right option for this question is A.